Hello and welcome back. I am Dr. Ananya Barua and we have been discussing the lecture series on philosophy of mind. Today we continue with yet another topic, and that is on embodied AI, philosophical insights and ethical challenges. Now, embodied AI refers to artificial intelligence systems integrated into physical bodies, enabling them to interact with the world directly. This approach contrasts with disembodied AI, which operates purely in abstract or virtual realms. The philosophy behind embodied AI highlights several key insights. Firstly, situated cognition. Embodied AI aligns with theories of situated cognition, which argue that intelligence is not only located in the brain, but is deeply influenced by bodily interactions with the environment. Philosophers such as Maurice Merleau-Ponty have emphasized how perception and cognition are rooted in the body. Extended mind thesis. Secondly, embodied AI intersects with the extended mind thesis proposed by Andy Clark and David Chalmers. According to this view, cognitive processes extend beyond the brain to include tools, technologies, and the environment. Phenomenology and subjectivity is the third insight. Embodied AI raises questions about whether robots can experience subjective states, while traditional phenomenology like Husserl centers human consciousness. Embodied AI prompts reinterpretation, challenging what it means to perceive or be in the world. Further, agency and autonomy. By granting AI systems bodies, their decision-making and interaction capacities become more nuanced, leading to philosophical debates on agency. Can such systems truly act autonomously, or are they bound by their programming and environmental constraints? Is one such recurring question that often comes up. So, we would now be discussing the ethical challenges in embodied AI. The physical integration of AI systems into the real world brings complex ethical concerns. The first, moral status and rights. If embodied AI systems display behaviors resembling sentience, questions arise about their moral status. Should they be afforded rights, or are they merely tools? Responsibility and accountability. Embodied AI systems interacting autonomously in the world complicate issues of accountability. For instance, who is to blame if a self-driving car causes harm? The manufacturer, the programmer, or the car itself? Human-AI interaction. Embodied AI systems can blur the lines between humans and machines, leading to potential manipulation of human emotions, dependency, or dehumanization in social interactions. Embodied AI, by uniting physicality and artificial intelligence, represents a transformative shift in AI philosophy and application. However, the integration of AI into physical forms compels us to rethink notions of cognition, agency, and ethics. The future development and deployment of embodied AI must be accompanied by robust philosophical discourse and ethical safeguards to navigate its profound implications for society. Let us now quickly have a look at some of the philosophical insights vis-a-vis embodiment. First, embodiment or embodied AI as a ground for cognition. Embodied AI builds an embodied cognition, a philosophical and cognitive science theory positing that cognitive processes are deeply rooted in the body's interactions with the environment. Thinkers like Maurice Merleau-Ponty and Alvin Noé argue that perception and consciousness arise not merely from neural processes but through active engagement with the world. Challenges to Cartesian dualism. Embodied AI refutes the mind-body dualism traditionally associated with Descartes, asserting instead that intelligence and consciousness emerge from physical and sensory interactions. The problem of intentionality. Philosophers like Searle have questioned whether embodied AI systems can genuinely possess intentionality, that is, the directedness of mental states, or whether their behaviors are simulations without true understanding. Further, how autonomous can embodied AI truly become? Philosophical debates explore whether AI systems could develop agency akin to biological organisms, or if they remain fundamentally limited by their programmed nature. Now, when we further see the ethical challenges, we see it vis-a-vis the moral status and personhood. If embodied AI exhibits behaviors associated with sentience, should it be granted moral consideration or even legal personhood? This raises questions about rights, responsibilities, and the nature of personhood. Further, bias and interaction in embodied systems. The other ethical challenge in embodied AI systems, like social robots, can perpetuate societal biases if not carefully designed. How they interact physically with humans adds layers of complexities to these biases. Accountability and liability. Embodied AI systems operating in the physical world, like autonomous vehicles or care robots, introduce new questions about accountability for actions that lead to harm. Privacy and surveillance. Embodied AI often relies on sensors and data collection to interact effectively. This creates potential for misuse in terms of surveillance and violation of privacy. The other ethical challenge is the human-AI relationship dynamics. The integration of embodied AI into caregiving, companionship, and education roles can alter human relationships, raising concerns about dependency, emotional manipulation, and loss of genuine human connection. So, if we are really to think about the ethical considerations of embodied AI, there are certain future directions that one needs to look at. Some of these are the hybrid systems. Advances in neuromorphic computing and bioengineering could create embodied AI systems that mimic biological processes, further blurring the lines between artificial and natural intelligence. Ethical frameworks. Governments and organizations need to establish clear ethical guidelines for the development and deployment of embodied AI, emphasizing transparency, fairness, and accountability. Ongoing philosophical inquiry into embodiment, consciousness, and ethics is crucial to the evolution of AI technologies in ways that align with human values, and that is why the future direction vis-a-vis philosophical engagement is one of the most significant takeaways. Now, if one talks about AI-assisted co-intelligence, we would see that there have been a lot of challenges and certain philosophical insights of late. AI-assisted co-intelligence refers to collaborative intelligence systems where artificial intelligence and human intelligence work together to solve complex problems, generate knowledge, and make decisions. This paradigm amplifies human capabilities while leveraging AI's computational power, and it presents profound philosophical questions and ethical challenges. Now, some of the philosophical insights of the AI-assisted co-intelligence are: number one, redefining intelligence. The concept of intelligence evolves in the co-intelligence framework, highlighting the interplay between human creativity, intuition, and emotional depth with AI speed, pattern recognition, and scalability. Philosophers like Howard Gardner's multiple intelligences and Andy Clark's extended mind theory find new relevance here, as intelligence is distributed across human AI networks. Collective epistemology. AI-assisted co-intelligence can create systems where knowledge generation transcends individual or human-centric understanding, emphasizing collective epistemology. This raises questions about the nature and ownership of knowledge. Who knows when an AI human system generates an insight? Agency and autonomy. Philosophical debates explore how agency is distributed in human AI systems. Is AI merely a tool, or does its influence on human decisions make it a co-agent? Scholars like Latour's actor network theory provide frameworks for understanding non-human entities as participants in networks of action. Consciousness and creativity. Can co-intelligence ever reach a form of collective consciousness? While current systems lack subjective experience, their emergent behaviors provoke questions about what constitutes creativity and innovation. The human condition. AI-assisted co-intelligence prompts reflections on what it means to be a human. Philosophers like Heidegger and existentialists argue that technology redefines our engagement with the world, potentially alienating or empowering us. The ethical challenges, decision-making accountability. In co-intelligence systems, it can be difficult to pinpoint responsibility for outcomes. Ethical frameworks must address scenarios where human and AI contributions are inseparably linked. Bias amplification. While AI can reduce some biases, it may also amplify or introduce new ones, especially in co-intelligence systems that lack transparency or rely on biased data inputs. Inequality and excess. The benefits of AI-assisted co-intelligence are not equitably distributed. Unequal access to technology risks creating cognitive elitism, where only privileged groups can augment their intelligence with AI. Erosion of human skills. Over-reliance on AI for co-intelligence might lead to the atrophy of critical human skills such as problem-solving, creativity, and ethical reasoning. In fact, in the Oxford Dictionary of the Year for 2024, the most popular word has been the brain rot. Brain rot is thus an offshoot of such ethical challenges of AI-assisted co-intelligence, and that is for real. Fifth, manipulation and deception. Co-intelligence systems can be used maliciously to manipulate human perceptions, influence decisions, or spread misinformation, undermining trust and collaboration. Autonomy and consent. Integrating AI into collective decision-making processes requires clarity on how much autonomy humans retain and whether their consent is genuinely informed. So we see that there have been various challenges in the AI-assisted co-intelligence. It is not as simple, or it is not as grand as it might seem for a lot of us. Yes, it has opportunities, and yes, there have been a lot of benefits, but also let us be realistic here. Going further, let us discuss about the opportunities now for co-intelligence. A. Global problem solving. AI-human collaboration can address complex global challenges like climate change, pandemics, and poverty, combining AI's analytical power with human ethical reasoning. Educational transformation. Co-intelligent systems can revolutionize learning, offering personalized education while fostering collaborative, critical thinking. Further, enhanced creativity. AI can inspire new forms of artistic and scientific creativity by expanding the range of ideas and perspectives available to human collaborators. However, as much as there are opportunities and benefits, one needs to be mindful about the ethical safeguards. And what are these ethical safeguards? First, transparency. Clear documentation of how AI systems contribute to decisions is critical for accountability and trust. Inclusion. Co-intelligence systems should be designed to include diverse voices and perspectives, minimizing the risk of cultural or epistemic bias. Third, regulatory frameworks. Governments and organizations must establish ethical guidelines for the deployment of co-intelligence technologies, ensuring fair and responsible use. Augmentation, not replacement. Ethical co-intelligence systems should prioritize augmenting human capabilities rather than replacing them. Now, as a student of philosophy, there are certain further research questions that one can investigate. For example, questions like, can AI in co-intelligence systems ever achieve moral reasoning akin to human ethics? How will co-intelligence reshape traditional notions of authorship and originality in creative works? Can AI in co-intelligence systems ever achieve moral reasoning, which is equivalent to ethics? The question of whether AI in co-intelligence systems can achieve moral reasoning akin to human ethics is deeply complex and touches on philosophical, technical, and ethical dimensions. Let us have an analysis of the key issues. 1. Nature of moral reasoning. Moral reasoning in human involves cognition, understanding principles and rules, emotion, empathy, compassion, and moral intuition, experience, learning from context, culture, and personal history, reflection, evaluating outcomes and intentions. AI systems, even in co-intelligence contexts, operate fundamentally through algorithmic processes. While they can stimulate aspects of moral reasoning, they lack subjective experiences and intrinsic motivations that form the basis of human ethics. Current capabilities of AI rule-based ethics. AI can follow ethical frameworks like deontology, utilitarianism by applying programmed principles. For instance, autonomous vehicles prioritizing lives based on predefined rules like minimizing harm. Contextual analysis. Machine learning enables AI to adapt decisions based on patterns in vast data sets, offering context-aware ethical decision-making. Example, AI in healthcare recommending treatments based on patient demographics and medicinal history. Simulation of empathy. Natural language models and effective computing allow AI to mimic empathetic responses, though these are devoid of genuine emotional understanding. There are also certain philosophical challenges. Lack of subjectivity. AI does not experience pain, joy, or empathy, which are integral to human morality. Without these, can AI decisions be truly moral, or are they merely calculations? Moral pluralism. Human ethics is culturally and contextually diverse. AI systems risk imposing uniformity or perpetuating biases inherent in their training data. Intentionality and free will. Moral reasoning requires intentionality and the capacity for free will. AI lacks both, acting as a deterministic system guided by programming and data. Unpredictable outcomes. AI decisions, particularly in machine learning, can be opaque, that is, the black box problem, making it challenging to ensure ethical reasoning aligns with human intentions. Can AI simulate human-like moral reasoning? AI may approximate moral reasoning in the following ways: ethical decision models, training AI on ethical dilemmas, for example, trolley problems, to make consistent choices; contextual sensitivity, incorporating cultural and situational nuances into AI frameworks; collaborative oversight, co-intelligent systems where human input guides AI decision making, combining computational power with human judgment; limitations of AI in achieving true moral reasoning, emotional understanding. AI lacks emotions and the capacity for moral intuition, which are key to human ethical judgment. Moral growth. Human morality evolves through experience and reflection. AI lacks this ability to grow or learn in the same experiential sense. Intrinsic motivation. Human ethics often stems from an innate desire to do good. AI has no such intrinsic drive. Its actions are always instrumental. Future possibilities. While AI may never achieve moral reasoning akin to humans, it could become an effective partner in ethical decision making. Augmentation, not replacement. AI can provide insights, weigh alternatives, and identify potential biases in human reasoning. Embedding diverse, robust ethical frameworks into AI to guide its decision in morally ambiguous scenarios could be like, for example, emergent properties. Advances in neuromorphic computing and embodied AI might lead to systems that demonstrate emergent quasi-moral behaviors, though this would still lack true consciousness. The key takeaway, if we are to connect, could be AI's moral reasoning will likely remain a functional approximation of human ethics rather than a genuine replication. Co-intelligent systems will need to balance AI's computational strengths with human emotional and moral depth, ensuring ethical decisions reflect shared human values. Examples of AI in ethical decision making, if we are to make a note, we would see that AI is already playing a role in decision making processes with ethical dimensions across various domains. Below are some notable examples where AI's capabilities and limitations in moral reasoning are evident. 1. Autonomous vehicles scenario. Self-driving cars must make split-second ethical decisions in scenarios like the classic trolley problem, where, for example, deciding who to protect in unavoidable accidents. AI's role. Algorithms are trained to minimize harm using decision trees and probabilistic models. Data from real-world driving conditions informs the AI's understanding of accident scenarios. Decisions often lack transparency. Passengers may not know the ethical logic behind the AI's actions. Cultural differences affect how harm is prioritized, sparing the elderly versus children, for example. AI in healthcare scenario. AI is used for diagnosis, treatment recommendations, and resource allocation in emergencies. Example, COVID-19 vaccine distribution. AI's role. Predicting disease risk and prioritizing care based on algorithms trained on demographic and medical data. Assisting with triage in emergencies to allocate limited resources ethically. The limitations. Bias in training data can lead to unfair outcomes such as underdiagnosis in minority groups. Ethical dilemmas arise when AI recommends cost-effective treatments over more human options. Predictive policing and criminal justice scenario. AI systems like Compass assesses recidivism risk to guide parole and sentencing decisions. AI's role: analyzing historical data to predict the likelihood of reoffense, supporting decision makers with probabilistic assessments. Limitations: AI systems have been criticized for racial and socioeconomic bias. Reliance on flawed data perpetuates systematic inequalities rather than addressing them. Disaster response and humanitarian aid scenario. AI assists in distributing aid during natural disasters or managing refugee crisis. AI's role: using satellite imaginary and predictive models to identify regions in greatest need. Allocating resources based on objective criteria like population density and vulnerability. Limitations: decisions may overlook cultural and social contexts, leading to ethical concerns. Lack of human empathy can result in insensitivity to local needs. AI in environmental ethics scenario. AI helps in balancing environmental conservation efforts with industrial development. AI's role in predicting the impact of human activities on ecosystems, recommending strategies for sustainable development. Limitations: ethical priorities, example, valuing economic growth over environmental protections, can be embedded in algorithms, leading to biased outcomes. So, we would be furthering our discussion on AI vis-a-vis the emergent behaviors in AI system in our next class. Thank you so much.